This is the presentation for the heat transfer material as a new radiator coolant. Okay, we will add graphene into a new heat transfer material as it has more than 1000 watt per kilo uh, material, and it can produce instant heat transfer and remove heat capacity at a higher rate and also store the heat in the ethylene glycol. As such, the product will have high heat transfer conductivity, higher thermal conductivity of 25%, and it increases the heat transfer capacity by 20%. So these are the common usage for coolants, and coolants are highly used in many places such as machining, automotive application, and also power plant. We are targeting automotive. It is the easiest to penetrate and high demand in the local market. So this is the submission for the PI number that we have done. And for automotive, a lot of heat is actually dispersed in terms of heat, and we are having a losses around 30%, 33% in this case. Okay, the loss of heat actually causes by poor thermal conduct fluid, and the reach of the radiator, current radiator, is actually slightly bigger, and it's consume the space and increase the weight of the car. If you can somehow reduce the size of the radiator and improve the thermal transport of the fluid, we can solve this problem easily. So these are the common automotive cooling system components. So we can see a lot of design of the cooling system, and the power coolant is the base for the uh, heat transfer enhancement that we are targeting, and a lot of heat transfer for thermal is required for the engine. So this is a summary of the literature review, and this is summary of what are the steps to do the methodology for the nanofluids. So when we talk about graphene, it is a single cell carbon layer. It can be used in fuel cells and supercapacitors as well as cell batteries. And the object of graphene is important because it has high thermal conductivity. In terms, it can reduce heat by 1000 watt per Kelvin. So these are the graphene properties. It has high physical and morphology properties, hydrophilic, high surface to volume ratio, and it is a chemical modification, and is also, in this sense, it is biodegradable. So this is the method that we use. We start off with the preparation of the nanofluid, and then we go on and do the stability, and we test into the radiator, and we found the data analysis. So this is the experiment setup for the testing of the nanofluid. So we will try to use a radiator test rig, and this radiator test rig has been verified by many journals and publications that we are using it for nanomaterial testings. So this is the stability measurement for each of the concentrations of the graphene. So we have done 1 month preparation, and after how many days we will look at the observation and find the stable liquids. So we are looking at all these parameters: thermoconductivity, density, specific heat, and also the dynamic viscosity. The thermoconductivity, as we increase the temperature, we know it is increasing as the ethylene glycol is varied also. So in terms of thermoconductivity alone, we can compare with the 1.3%. It has the highest enhancements around 28.9%, and the minimum enhancement also is around 7.02%. But we are looking at other properties after that so that we can conclude this. So this is the viscosity measurement. So viscosity also is improved, and maximum density also is improved, and specific heat capacity also is improved. And when we look at the test rig, we can improve in terms of Reynolds number, Nusselt number, and the heat transfer rate. So Reynolds number, all this is measured here. Okay, in terms of the pump performance, so we can see that the heat transfer and the Nusselt number is increased, so that it shows that the pump has less energy usage, and it can be used to uh, increase the heat of the fluid from the engine to the surface of the radiator fin. So this is a thermographic image that we took for the nanofluid, and we can see the highest uh, distribution of the heat is at the center of the radiator. And we also did a corrosion test so that whether the liquid is corrosive to the radiator liquid, and we can see that it is around less corrosion in terms of this figure. As a conclusion, we can say that the graphene in ethylene glycol produces a stable nanofluid with a thermoconductivity increase from 0.487 to 0.632, and the objective of creating a fluid that is zero point 0.5 concentration and improve the viscosity by 7.4%. And moreover, the investigation on the effect of erosion of graphene coolant on the automotive radiator also were carried out, and the graphene nanofluid is an efficient radiator coolant in terms of this product. So we can give a recommendation based on the nano substance, because it doesn't uh, destroy the engine, or it doesn't influence the engine so much, and the base fluid is still the same, and we can use in radiator and for the wide range of temperatures that can be used. So these are the publications that we have done. We have published ISI papers or Web of Science, and we have accepted one paper also in Web of Science, and two conference paper also has been done by our group. Okay, so the group consists of myself, Dr. Devarajan, Sandhya is our student, and Dr. Kumaran also is there, along with Sudhakar, Sambikano, and also Wan Sharuzi for the other papers. So these are the list of reference, and thank you very much. So if any questions, you can ask us later on. And these are the collaborations that we have already done, which is the Professor Horizon from Focus Applied Technologies, and also some collaboration we have done with BMW. We are asking them last time before COVID happens, and hopefully we can move on with our local partners. So Gagasan Global Center Bahad also. Okay, so thank you very much, everybody.